The goal of this part of the lecture is to introduce some concepts and constructs that will help us identify impediments and even propose solutions. The first set of concepts that I want to introduce are efficiency and robustness. Now, these are terms you're probably familiar with, but we're going to define them a bit more precisely, and more importantly, it's pretty much the case that the concepts of efficiency and robustness are, in fact, very similar to the technical terms of efficiency and robustness are similar to the everyday usages that you're accustomed to. So an efficient system is one that minimizes costly activity. So what you want to do is, for example, eliminate redundant steps, eliminate any steps that are duplicated, or eliminate people that are duplicated. And in general, with an efficient system, part of the idea is that control over the system typically can move down somewhat to the producers, the people who are sort of on the front lines, because they're often going to be the ones who are the most efficient at doing activities. The problem, of course, is that if you've got a very efficient, fast, streamlined production process, it may be quite prone to errors. Or if there's a single person who gets removed, or a single machine breaks down, then everything falls apart, very much as we saw in the case of the fire jumpers or smoke jumpers, when a single walkie-talkie broke and was damaged because they didn't have redundant walkie-talkies, they could no longer communicate. So efficiency might not have been what they actually wanted at that point. Instead, what they might have wanted was robustness. So a robust system is one which is designed to minimize disruptive errors. So it's often the case when you engineer a nuclear power plant or when you engineer an electrical grid. You don't want a single failure or fault in one part of the grid to sweep out and affect all the parts. You want to make sure they stay contained, and ideally that the same function is there's a backup to it. So it's like having a backup battery or a backup generator on the house. So in fact, what you want are multiple redundancies. Now those may be expensive, but it ensures continuous service. And in the case of robust systems, it's often the case that there's a little bit more control given to managers, though there are some exceptions to that. Of course, the complication of having a robust system is that they can be quite time-consuming and expensive, and many of the redundancies may in fact appear unnecessary, and sometimes it's the case that organizations paring down will almost forget why they originally designed a robust system. And the target population will often complain about red tape or slow processing times. So this is a symptom often of a system that is designed to be robust, and so when you tend to see target populations or any type of complaint about red tape, think to yourself, maybe this is something about being a robust system. Now, again, it doesn't mean that all red tape is good, because there's always a trade-off between efficiency and robustness most of the time when designing systems. Now, the next set of concepts we're going to introduce are demand-driven versus supply-driven activity. So a demand-driven activity is one in which the customer shows up and you have to immediately supply what it is that they want. And so it is the customer or the purchaser of the good or service that is driving the fluctuations in activity load. So I tend to think in the teaching context, for example, that people coming to office hours is a demand-driven activity. Receiving emails is a demand-driven activity. I can't control how many emails a day I get. Some days there's a lot, some days there's little. Supply-driven activity is one in which the producer has some control, not the consumer. So, for example, a large lecture, I get to control when, where, how it gets delivered to a far greater degree than I can how many emails I receive in a day. Now, it turns out that demand-driven activities can cause many of the types of clogs, as one can imagine. In essence, what you have is almost like periodic flooding of activity. So this is a little actual real-world example of a case in North Carolina where a department, the Social Security, the department that was responsible for Social Security checks would every month mail them out on the same day, right? The Social Security recipients needed to have their checks on the same day every month. So the first of the month, whoever it was in the government department would make sure all the Social Security checks went out. Now, what ended up happening then was that mail would go to the Raleigh post office. They would then sort and process the mail, and the local post office would deliver the mail. Now, of course, if you've got all the Social Security checks going out on the same day, that means there's a sudden surge in demand on both the Raleigh post office and the local post offices, and often they couldn't cope. And as a result, there were often complaints about delayed and lost checks. Now, this was in essence a clog in the system where too much would come in at one time. You couldn't staff a post office just for the first of the month. So it's often the case, for example, a post office around Christmas when they have a surge in demand might hire additional people to take the additional packages, right? It's some absurd number of packages and cards that get delivered in the month of December. And so often they'll have to hire additional people, but they couldn't do that just for the first of the month. So what the government department had to do as a way to design around this was, in fact, to realize that they didn't have to send out every check the first of the month. What they could actually do was split the alphabet into 20 equal parts for the 20 business days in a month and send out 1 or 2 letters of the alphabet each day and basically smooth out that demand and smooth out that clog, and the number of lost and delayed checks. So security checks went way down after this change was implemented. So again, here are the basic definitions of demand-driven versus supply-driven activity. The big thing to look at here are that the symptoms of supply-driven are that target population will often complain about poor service because they, in essence, aren't getting the customized responses so that they want. So, for example, I may be lecturing and not answering your questions, and so you'll be like, oh, they didn't cover this thing I really wanted to have, and so it's not really as great a lecture as I want. However, when you get demand-driven activity, you tend to see another set of symptoms, and those tend to be that employees who get very stressed but then have lots of time to just sit around and play Minesweeper, right? So they'll have peaks of stress and then sort of lulls. So again, it's not always the case, but these symptoms can help us. If we start to see these characteristic complaints in a case, you might need to go back and check the types of activity and see whether or not, in fact, you can identify whether activity might be supply-driven or demand-driven. We will see definitely some instances of this throughout the term. So this is just a graphical depiction of exactly what we talked about before with the regulation of demand. Another great example of a demand-driven clog, which I mentioned briefly in class the other day, is the idea of restoring power after a storm. So again, you've got this exogenous shock that's going to come in and knock out the power. The power company needs to restore the power, and if there's no power, the customer is going to call and answer the phone calls. So the power company has to answer the calls. So you can imagine that after a storm, a power company is getting so many calls. And in essence, the demand itself is caused by this exogenous shock. But in addition, you've got these multiplying phone calls as people try to figure out when their power is coming back on. Now, this is a little mechanism that is useful to think about, which is that in essence, from the customer's point of view, so we're going to think about the customer psychology, they understand that there was an exogenous shock, but they expect the power company to restore their power. And if they don't get concrete information about when their power is going to come back on, in essence, the stakeholder gets dissatisfied. So what they see is that they don't have power. It's the power company's job to provide it. They aren't getting that information. They're going to be dissatisfied. However, if they can seek information and get that concrete information, then they can end up satisfied because in essence, their understanding is matched with the information that's providing them. They expect them to turn it back on. They don't necessarily expect it right away, but they expect it to be turned back on. They're told when it's going to be turned back on, and all of a sudden they're satisfied. So it's often the case that when you think about psychology, you don't think that people have limitless demands, but that the most important aspect of understanding how customers and other types of target populations are going to respond is to understand that what they try to do is manage expectations. So you want to match an expectation to the result that they get. If you've ever dealt with small children, you know that a lot of what you're doing is managing expectations down, right? You're always trying to tell them, don't expect too much. We're going to get, or you're just saying, okay, we're going to have to clean up, and then we will go get our snacks. So that you're always sort of pacing out and managing the expectations of what's going to happen next so that people don't get frustrated. You're managing frustration levels in that way. However, I'd like to point out that it's not always the case that you can manage expectations and that will be enough. So let's compare the case of the power company that gets hit by an exogenous shock with a delay, say, in cable phone internet installation. In this case, we don't believe that out in the world as a customer, you don't believe that there is an exogenous shock. Well, maybe if it's right at the beginning of the academic school year and you know that Verizon's going around and hooking up a lot of student housing, okay, fine. Maybe there's a bit of a delay. But in general, one would expect there to be a fairly consistent set of people moving at all times of the year. So whenever you're told there's a 10-day wait, you think, that doesn't make sense. I believe that they should be able to staff appropriately, that there's not a particular peak time right now. And so in this case, even though you're trying to manage their expectations and tell them it's a 10-day wait, because it doesn't match up with what a customer would expect to receive, then you start to think maybe the problem is actually the phone company. And then when in addition you go and you tell your friends, oh my God, you wouldn't believe that Verizon was slow, or that Comcast was slow, or I used to say the BT was infamous, British Telecom was infamous for this. They never, always a 10 to 14-day delay. And then your friends would be like, yes, the same thing happened to me. And then you would say, okay, well, did you move in the same month? Was there a particular surge in demand? No. And so you still end up with, even if you've managed them through concrete expectations, it doesn't mean that stakeholders are going to end up satisfied, because again, it depends also on these things that they attribute the delay itself to. How does one then go about, once we understand the concepts of, say, clogs, the different types of efficiency versus robustness, demand and supply-driven activity, how do we go about addressing these clogs? And part of it is there's no single magic answer, and that's a big part of what I'm trying to teach in this course. What we want to do is consider a set of questions quite systematically. And the questions might be things like, if we're going to address a clog, does the change that we're suggesting balance the need for efficiency and robustness or effectiveness? Because there's also effectiveness, which is the idea that the outputs are what we actually want them to be. We might also think about if we have to have a change that, say, increases our efficiency but introduces a bit of fragility to the system, perhaps there's a compensating feature that can help restore some of the robustness, but at a lesser cost. And we also can think about things like, in the great plumbing metaphor, actually diverting pressure. And so this is the reason I find the plumbing metaphor to be so useful, is because we think, okay, the pressure is all coming at the point. It's all coming at the call centers. Can we divert it by, say, managing target population attributions or expectations? Sometimes you can divert it by changing the actual flow of work. But if you think about sort of water moving through a system and putting pressure in different places, this is exactly the metaphor that can help us understand how to address these clogs. Sometimes, just like a great plumbing clog, you might just need to work around it. If you can't manage a clog, though, in the Raleigh post office, and you can't manage a clog in the case of, there's nothing you can do if there's an exogenous shock and all of the power goes out in a third of your service area, what you have to do is, to some extent, in the Raleigh post office case, you can internally regulate demand. So that means instead of sending out all of your letters at once, you send out a third, 5% a day for the 20 work days. You might also, again, be able to divert the pressure. This is the idea of managing target population attributions. But a big question you have to ask yourself in the end, in really assessing how effective these solutions are going to be, is going to be whether or not the clog is going to be related to organizational outputs and organizational impacts. So the outputs are the concrete outputs of your input-output production function. The impacts are the things that you care about more broadly. So, for example, a firefighter doesn't just care about putting out fires. They might care about protecting public safety and health. So sometimes it might be that a firefighter needs to hold off for a second on putting a fire out in order to rescue a human. And that is actually completely consistent with the desired impacts and outputs that a firefighter is hoping to achieve. That is it then for the second set of concepts.